PinCode, 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 PinCode,
Building metal wings to fly won't take you to the stars. Use the metal for a boat and you won't sail too far. Stop sitting in the dark, stirring metal pots about. You will change your life forever when you figure out
the secret PinCode, 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 PinCode,
Science can be tricky, it can overheat your brain. Science can be hard to chew, each bite can be a pain. Stop sitting in the dark, stirring metal pots about. You will change your life forever when you figure out
the secret PinCode, 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 PinCode,
the secret PinCode, 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 PinCode.
Ladies and gentle creatures, it's that time of year again. Cast your eyes on this fierce competition for Miss Macrocosm. Tonight, you will determine the winner by means of popular vote.
Hey, don't forget that you promised her your vote. Don't forget our deal.
There can only be one. But who? It's unanimous! The votes are in! According to our audience, this year's Miss Macrocosm is, unsurprisingly, Rosa! Congratulations, friend! And now, let's see what you've won!
Come on, Chef, let's eat!
Best cake in the universe. Miss Macrocosm, made for you.
Fantastic!
All good. Oh, Rosa, just like the macrocosm itself, like all space, you just remain the same.
Well, actually, Wally, space is always changing. The universe is expanding and we'll keep doing it forever. Kind of like, a balloon.
No!
Can the universe grow until it explodes?
Oh, of course not. Let me explain it to you. At one time, the universe as we know it didn't even exist yet.
So where was it? Sleeping?
Not exactly. Before the universe, there was no mass, no energy, and even no time.
Ooh, look! I'm gonna touch the thing!
Stop! Better give that thing some space. At least a few billion miles worth of space. That tiny speck houses everything that will ever exist. And it's about to get a big wake-up call right about now! Welcome to the Big Bang! This is the moment at which time and space start to exist, and matter, and mass, and energy, and everything in between. These particles sped out from that explosion and eventually started to form stars and planets.
It took 13.8 billion years for the universe to expand and create our world as we know it today.
It's still speeding away?
It's not just speeding away, Crash. It's getting faster and faster. It's the opposite of what you'd imagine, right? Scientists aren't exactly sure why this is. There's matter called dark energy that fills up most of the universe we can see. Our macrocosmos is expanding and we don't know why. We've got no idea.
I am expanding, just like the cosmos. Just no point in denying it. Tomorrow, I'll change. It's time for a workout. Whoa, what's this? Oh! What's going on? Anyone there? What is this? Who are you?
I am the universe. I'm everything. The expanding cosmos. And you are?
Oh, I'm Miss Macrocosmos, beauty queen. Though recently I've gained a few inches here and there.
Gained a few inches, huh? Oh, friend, I grow millions and millions of miles every second.
That sounds a bit dangerous. I'd be afraid that one day I just might, explode.
Explode? Explain.
Like this. Watch.
How do I stop it?
It's self-discipline. Just avoid carbs.
Oh, come on now. But bread is so good.
But so is not exploding. Let's be diet buddies together.
Phenomenal! I'm baffled, but our universe has stopped expanding. And actually, it's shrinking.
I can't believe it. Hooray! Atta girl! She's doing it!
There's nothing good about this!
I don't feel like things are shrinking.
We can't be shrinking.
This is a big deal here. Scientists have confirmed that the universe is shrinking.
How'd they do it? A big tape measure?
I don't think that's what universal size means.
Super long!
Not quite. Astronomers use a tool that is much more precise than that, which is light.
Light?
Of course it's light. In space, distance is measured by light years. 1 light year is the distance light can travel across the vacuum of space in 1 year's time. And there are thousands and thousands of light years between each star.
I still don't get it. We use light to measure space? And we can see that it's shrinking?
Easy. We know light is made of many different colors and waves. The color we see depends on that light ray's wavelength. Here's how scientists know which wavelength is which. Red has the longest wavelength, while violet has the shortest. Stars usually glow yellowish white. They're constantly moving, which is how we can see them. The color of a star can tell us which way it's moving in relation to us. For example, if a star is coming near us, the light appears blue because of the shorter wavelength. And if it's speeding away from us, that light appears more reddish. The wavelengths are longer.
So, if the universe expanded away from us, the stars would be redder?
You're precisely correct. Even now, the stars are changing. Now they're blue, so the universe is shrinking. It's coming in quickly.
Who cares? She's a beautiful universe. It's her choice.
Well, we should care if we want to survive. This has some serious implications. Shortly, it seems the cosmos will reverse back to the Big Bang. Just a small dot.
So we'll get squished?
We won't feel it. We'll burn up long before that happens. As stars get closer, the temperature will continue to rise. and all life will become extinguished in fire.
We'll explode, huh?
No, first we'll catch fire.
Man, this is gonna be crazy! What a ride! Whee!
Hey, Miss Universe!
Hey, workout pal! So, notice anything different? Like a few billion light years? Soon I'll be my goal size. My pre-Big Bang weight. Just a point.
Listen, you're setting impossible standards.
You're jealous?
No, actually not. Why, you're looking blue. And it's getting too hot.
But it is my choice. Plus, I don't even crave sugar anymore.
But you're beautiful just as you are. The wonderful, endless universe. You're all that is. You can't let your size define you. Plus, there's no point in lying to ourselves. Bread is just perfection.
I don't know. You're saying I should expand, huh?
Just be yourself, girl. Everyone benefits from just being themselves. I should know. I'm Miss Macrocosm.
I'm the universe. I should decide for myself what beauty means. I reject ridiculous beauty standards. I am the all-powerful. And you're right, bread rocks.
Yeah!
Well, I guess this is it. We'll all be swallowed by the cosmos.
Question. Do you spell it last testament or test-o-ment?
Oh, Will, no one will be here for your stuff.
I have good news! The universe is going to be just fine!
Ha! You guys, we all get to live another day! Hey! Who said you get all the cake, Missy?
You're welcome for saving the universe. She's beautiful. And so am I.
Eat up, Rosa. I think we can all agree you're perfect. How you are.
Agreed, agreed.
Miss Macrocosm.
The universe's expansion was discovered by 3 scientists, Saul Perlmutter, Brian Schmidt, and Adam Rees. They figured out that the universe was expanding, though we still can't pinpoint the reason. They were each awarded the Nobel Prize for their astounding discovery.
Phenomenal! When we look through the telescope at faraway planets, stars, and galaxies, we're looking not only through space, but also through time. The light that we can see needs some time to reach us. When we look at the sun, for example, we actually see it as it was 8 minutes ago. That is the exact period of time that it takes for light to cover the distance between the Earth and the sun. Taking a photo of the closest star, Proxima Centauri, gives us an image that's almost 5 years old. So we see faraway galaxies as they were millions of years ago.
Wunderbar! So you're saying when we look at the stars, we see not only far away, but back in time?
Precisely, yes.
Space is just really boring.
But Crash, you're the one who wanted to come.
You're right, I did. But I was thinking we'd meet cool aliens and stuff. Have battles with guns that say pew, but there's nothing out here. Nothing but empty space and twinkling stars. And we could see that stuff from Earth.
Daco thinks that we're pioneers, trailblazers here at the dawn of space discoveries. That means every space experiment we do is of great value to the future. When you think about it, it's exciting.
Right, that's about as exciting as math. I want some space pirates. Pretty please. Ah. Well, look at that. That'll work.
Crash, are you sure this wasn't, important?
I'm making it better.
Colleague, please be very careful. This is a crucially vital experiment.
Yeah.
System ready to start.
All Despite cunning invaders from the long-ear cottontail cluster, you will not last very long up against Captain Fuchsia's spiky head.
Give up, creatures of the earth. Swear your allegiance to the cosmic carrot or else perish.
A firm no.
Fellas, since you're not doing anything that matters, come on up! We found something awesome! Just phenomenal!
So, what's so awesome and phenomenal?
Right there! Right there! Our sun.
The sun is the star that binds our solar system together. Everything in our system revolves around the sun. The 4 terrestrial planets, 2 gas giants, 2 ice giants, and all their satellites, and the asteroids, meteorites, comets, and space dust as well. The sun's mass makes up 99.8% of the whole solar system's weight. Our ancient ancestors recognized how much their survival depended on the sun. Because of this, there were many ancient cultures that worshipped the sun. While our understanding of the sun's properties and processes has grown, and we no longer worship it, its size and position in relationship to the Earth remain vital to the survival of life on our planet. If the sun were any bigger or closer, Earth would be too hot for life to exist. And if the sun were any smaller or further away, Earth would be too cold for life to exist. While the sun is the biggest body in our solar system, in comparison to other stars in the universe, it is an average-sized star, sometimes called a yellow dwarf star. The closest star to our sun is Proxima Centauri. It's about 1/7 the size of our sun and is 4.25 light-years away. That means the light from Proxima Centauri takes 4.25 years to reach Earth. Sirius, which is 2 times heavier than our sun, is 9 light-years away. And Arcturus, which is 25 times bigger than the sun, is 36 light-years away. The largest nearby star is Betelgeuse. It's 1,000 times larger than the sun and is 500 light-years away. Our sun is about 150 million kilometers from the Earth, or about 8 light-minutes away. Today we know a lot about the sun, and scientists are always searching for more knowledge. We know the age of the sun, its radius and weight, though visiting the sun ourselves is still a long ways off.
So what? You know you can see the sun from Earth, right?
We're here for more than just a regular old gander at the sun. We're about to conduct a very important scientific experiment.
What do you plan on looking at the sun with? A nerd telescope or something?
Nothing like that, my bored, floppy-eared friend. We're going to be trying out a brand new, exciting method of traveling in space.
What's wrong with the old one? Besides, you know, that it's old and stuff.
When night fell and our ancient ancestors could see the stars, some dreamt of exploring space. Throughout history, people discovered new and better ways to travel by land, by water, and eventually even by air. But airplanes rely on atmospheric pressure, so when we pass through our atmosphere and into space, there is no pressure to hold us up. We need another way to move ourselves through airless space. The answer to our problem was jet propulsion. Propulsion relies on Newton's third law of motion, that to every action, there is an equal and opposite reaction. Propulsion shows up in the animal kingdom. For instance, an octopus will propel itself along by sucking water in and then pushing it out. This propels the octopus through the water. Another example of propulsion is the motion of a boat when a person pushes off of it to jump in the water. The boat reacts to the pressure of the jump and moves away from it. Motion occurs in space because the rocket uses an expulsion of fuel to push itself forward. No air is necessary because the rocket is responding to the opposite pressure of the fuel. A rocket must have enough energy to escape the Earth's gravity. At liftoff, the rocket's thrust is created by solid rocket boosters pushing upwards. Russian scientist and physics teacher Konstantin Eduardovich Tsiolkovsky played a key role in the development of jet propulsion by suggesting multi-stage rockets. Multi-stage rockets drop off sections of the rocket as the propellant is used up. This decreases the mass of the rocket, making it easier for the next propellant to push the rocket even further.
Groovy as jet propulsion may be, it has one very serious drawback.
What drawback? Look at it! It's awesome!
To get very far using a jet engine, you'd have to carry way too much fuel.
But how do you fly once your fuel supply runs out?
Well, we might run across something that can give us a little push. For example, the sun.
For real? Holy carrots, how is that?
Not quite, because the sun hasn't any hands, but it can push all the same with its shining light. Pretty interesting, am I right? Light puts pressure on the items that it hits. Only a little pressure, and yet, out here far away from gravity, that tiny pressure just might help us.
Peter Lebedev, a Russian scientist, was the first to measure the pressure of light on a solid body. He took a silver thread, placed a small foil propeller on the thread, and then placed this into a glass flask. He then removed all of the air, and when he directed light from a lamp on the flask, the blades began to spin. Almost 400 years ago, German scientist Johannes Kepler suggested that a solar sail might be used for traveling through space one day. Different space agencies are now planning and building some spacecraft with limited solar sails. But to explore interstellar space, we would need to build sails that are many kilometers across.
But of course, then they didn't have the technology for the creation of the large-sized cloth solar sails required, and so the concept was put on hold until a more advanced
And
era.
that era is today. We have been able to fabricate a solar sail prototype with the required size and properties.
Solar sail is damaged. Attention, solar sail is damaged. Attention, sail is damaged. Hello? Is this thing on? Your sail is messed up, yo.
Stop the deployment process! If it spreads out in its current state, the solar sail could be ripped to
I
shreds!
can't stop it. The process is automatic once you started it.
We've been preparing this for months! A one-of-a-kind experiment! Months of careful preparation! Oh, months! Not weeks, not days.
Hey, I was hugging that.
I don't know if this matters, but unauthorized spacewalk in progress.
Just let me get us a better picture.
It's Crash. Look.
The sail is still spreading out! Danger! That is dangerously dangerous!
Solar sail 75% deployed.
I find this very stressful.
Huh. Solar sail successfully deploying. The bunny rabbit did it.
Phenomenal! All right,
That's
Crash!
not resourceful.
Wonderful
brave,
work, dear
clever,
friend!
Fluffy tail.
Come back inside! I want to shake your hand! What?
This looks like a job for jet propulsion. Yahoo! Oh, oh, oh.
Solar sail completely deployed. We are sailing on the solar wind.
Happy birthday to you. Happy birthday to you. Happy Happy birthday, dear Rosa. Happy birthday to you.
Now it's time to, set off the fireworks, right?
Fireworks! Fireworks! Fireworks!
The natives are getting restless. Hurry up there, Daco.
Cool your horns, my impatient friend. Accuracy is most crucial in this process, as is being cautious. Whew. Be careful with these things, Wally, please. They can very easily go off by themselves.
What have we done? Please say you can invent more fireworks.
Well, first, this was not remotely my fault. And then second, where can I find more firework ingredients? We're flying through space!
This is bad.
Although... Hey, yeah!
What's happening? It's fireworks time, isn't it?
Just give me a few moments here, my lovely birthday girl. There's a little question I'd like to ask everybody first. Here it comes. What do you know about the life cycle of a star?
What do you mean, a star's life cycle? Stars just shine forever, right?
No, siree. Just like everything else, stars come into the universe, they live, and they die. The process just takes much longer with stars. Very much longer, in fact. It takes billions of years.
A new star is created in a cloud of dust and gas called a nebula and consists mostly of hydrogen and helium atoms. When the dust and gas become heated through compression, if the mass of the cloud is dense enough, the temperature during the compression, as well as pressure, becomes so high that the atomic nuclei start joining and thermonuclear reactions take place. An enormous amount of energy is generated, and the compressed gas cloud starts shining, turning into a star.
Are you saying there was a time our sun was a cloud like that?
Like every star was, yes. But then, with time, it transformed quite a lot, growing into the sun, with which we're familiar. Thousands of years later, planets gradually formed around the sun. And one of these orbs eventually developed life. We're that life.
While I love party-killing science lectures as much as the next girl, I was promised fireworks.
Yeah, Rosa. But still, gee, this is interesting. And can you tell us the age of our sun?
We can roughly estimate that it's in the vicinity of 4.5 billion years old. It's been around a while. Certainly it's mature, not a little baby anymore.
Once a star has been formed, nuclear fusion occurs constantly in its core, using up hydrogen and releasing immense energy, enough to push against the force of gravity and keep the star in balance for billions of years. But this process is not infinite. Eventually, the hydrogen will be depleted and the star will either collapse or explode.
Goodness, are you trying to tell us that our very own sun is going to, come to an end?
What? Our sun will die? No more parties or fireworks? Hold me! Save the planet! Save the whales! Hey! It's a madhouse! A madhouse!
There is no need for any of us to panic! The life cycle of our beloved sun will not end soon at all. I'd say we have about 5 billion years before that.
I'm beginning to think nothing's going to blow up here. Are you telling telling me my birthday isn't worth fire in the sky?
Have patience, our dear porcine guest of honor. Something far better than fireworks is on the way.
Yeah, lots better, yeah. It is, right?
Precious friends, we have quite an enchanting opportunity to witness the end of the life cycle of one of the largest stars in our galaxy. May I present Betelgeuse?
Betelgeuse is one of the largest known stars and is one of the brightest stars in the constellation of Orion. Betelgeuse is 700 times bigger than our sun and approximately 100,000 times brighter. As is the case with all giant stars, Betelgeuse burns its hydrogen faster than smaller stars. It is believed to be in a late stage of stellar evolution and is expected to explode as a supernova within the next 1,000,000 years.
And what happens to stars when they get to the end of their cycle?
Hey, I know! They fall right out of the sky! If you see one falling, you can wish on it and stuff. But they're not as pretty as fireworks are!
You're wrong there. The final act in the life of a star is an awesome spectacle, better than the best fireworks display ever! We've come to the stellar neighborhood of Betelgeuse to view this breathtaking cosmic wonder!
Should we get closer? I can't see it! Just a bunch of regular old stars. So what? If we move closer to the star, is the ship going to melt or something?
I'm melting. This vessel is capable of withstanding ridiculously high temperatures.
There is no need to move closer, trust me. From this position, everyone will see everything clearly.
You can start the show now! Preferably while it's still my birthday.
Frankly speaking, it should have already started, according to all my calculations. I don't understand it. Sorry, let me just calculate all of it again.
Stop, sheep. You know how to drive the silly space boat, right? Let's fly a little closer to this star action.
But, didn't Daco say we could see it all from right here?
Well, Daco said a lot of stuff. He told us this thing was supposed to start hours ago. What if the show has started, but we're just too far away to see it? Sweet Wally, you're always so kind to me. Won't you give me this? For my birthday? Closer! Come on, fly closer! Oh, this is awesome! It's my birthday! Yeah! It is better than fireworks! Well, it is crazy warm, all right, but from here we will totally see everything!
Turns out I just forgot to carry the wand, silly me! And now I can say with absolute confidence, the spectacle will indeed be starting quite soon! Why are we right next to the star?
Much nicer view, right? I just thought we'd be able to see everything so much better from here.
You just don't understand a star's life! At the end of the life of a star, the close of its life cycle is an intense explosion! 10 seconds from now, Betelgeuse will increase its volume 1,000 times.
When there is no hydrogen left in the center of the star, fusion stops, and the star begins its collapse. This leads to intense pressure and heat, which in turn will lead to an explosion. Exploding stars become much bigger and brighter for a time. Sometimes the explosion of a star is the only time it is visible to us here on Earth. Exploding stars are called supernova. Betelgeuse may become a supernova sometime soon, although nobody can say exactly when it will happen. It's more likely that the flash of that supernova will be seen by a future generation. Perhaps they will see a second sun in the sky.
Yikes! Sweet sauerkraut!
Oh.
That was not fun. I'm getting way too old for this stuff. Dumb star.
That's just great. I was way too scared to even look at the explosion. All I wanted were some dumb fireworks for my birthday!
Look at that.
Of course. So, Beetlejuice has grown so much it's nearer the Earth. In fact, it seems it's shining bright enough now it's able to give our sun a little friendly competition.
Isn't it just beautiful? It's the best birthday in the history of forever. Forget silly old fireworks. I got a whole new star!
Boom! Crash! Stop being so silly! Are you ever going to grow up?
Interesting question. How can I have time stopped?
Ha ha! Very funny. Aren't you tired of this joke already?
How can I be tired of something if time is stopped?
Oh.
The annoying error has been fixed. Now I can say with complete accuracy everything will happen in some... why are we so close?
Cool, right? I thought we'd be able to see much better.
How is it you don't understand? When the Beetlejuice star completes its full cycle, it's going to explode! In 10 seconds, Beetlejuice will increase its volume by thousands of times. We won't have time. Spherejet can't possibly fly any faster than the speed of light.
Spheroscope! This is technology from the future. We can stop time for everybody except you and me and think something up.
Don't explain, my friend. Act now.
Engage. Full stop.
Holy carrots! Kind of neat!
Hey! And how do we get everything back?
It says here, to cancel time stopping, press this red button one time. Okay.
Stop! We'll burn up!
You suggest leaving everything like it is?
I don't know. If Doku and Pin were in our shoes, they'd think something up for sure.
Yup, but now it's our responsibility or something?
I'm just a girl. I don't want to solve anything. I want to close my eyes, and when I open them back up, everything will be okay. Crash! Be a gentleman or something, and do something which will save us. Think of something.
We don't have to think anything up. We just have to move the sphere jets farther away. Yeah! 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 working! I've already moved it a couple of millimeters.
I'll go read up about this. Mathematics, thermodynamics, optics, hydraulics, physics. Physics?
Ready? Set?
Stop it! That's not working!
But it's fun.
While you were having a good time, I was able to learn something interesting. Look here. This is our sphere jet, and this is Beetlejuice.
Looks a little bit off.
What's the difference? This is an example. Beetlejuice is expanding at the speed of light.
That means we need to fly faster than the speed of light. Talk about a task.
I thought about that at first too, but it turns out there's nothing faster than the speed of light. This rule is constant in normal space when light travels from point A to point B. But if we can bend space like a piece of paper, then it might be possible to trick the light and get from A to B faster. Scientists have even imagined such an invention. It's called a warp engine. It bends space in front of spaceships and stretches it out behind them. That way, the spaceship can fly significantly faster than the speed of light. The problem is, this engine hasn't been invented yet. So far, it's just a theory. But if we read a few more books, we could probably do it. Hey, who am I explaining all this to, huh?
Guess who?
When are you ever going to grow up, huh?
How can I even grow old if time is stopped?
Crash, don't you understand we're trapped? Nothing we do will work. The only thing we can do is press that stupid button.
The only thing that's not working is that you're not relaxing a little.
I don't have Doko's and Pin's knowledge. I've read all those science books over and over, and it's just no use to read them.
No more physics and mathematics. Fraulein, you won't understand these exact sciences anyway.
Do you think that's going to cheer me up?
Ha! My mathematical friend, Rosa the Physic. That's phenomenal. Well, I'll be darned. How long have I been asleep? We've been sitting here too long. Up and at 'em to exercise. 1, 2, 3, 4.
strings are unique objects in our universe which were only discovered very recently. The width of these strings is narrower than a single atom, and the length can span the entire universe. Despite its tiny width, its density is enormous. 1 kilometer of string is approximately equal to the mass of an entire continent on Earth.
But how will these things help us? Repair a violin?
I don't think so. Cosmic strings have one surprising trait. They appeared right after the Big Bang, when the universe had just begun to quickly cool. The same way cracks appear in ice after freezing really quickly. In the first moments after our universe appeared, so laws of physics were not the same as they are now. Even the speed of light was several times quicker, don't you know, huh?
Hey, what good times those were!
There's still some of that time left in cosmic strings. The theory is that to this day, there's some anomalies with the speed of time in these strings. If we fly along one of these strings, then we can fly quicker than the speed of light. That's it. The autopilot is programmed to fly along the nearest cosmic string. It should work. Theoretically.
And now we get to find out in practice!
Wait! If it works, then promise me that you'll never grow up.
It's a deal!
We've all been saved? But how? I don't remember anything.
That's a side effect of stopping time. We don't remember anything that happened.
That's a shame, as I'm curious how we were able to outrun the speed of light. And why did we need these strange accessories?
I'm afraid that we will never know that.
Hey, who put this on me?
It looks good on you.
Ha ha! Very funny. When will you ever grow up at last?
Get a single night's rest here.
Not
I may
again.
as well go back to
What
being
is it this
nocturnal
time?
because this is ridiculous. Every night this happens. If one person makes some early bird joke, I'm going to lose it.
Oh, what's wrong? The alarms are blaring.
I must tell you something. I hate to be the bearer of bad news, but this is important.
Are we being, audited?
Nah. It has to do with my particle accelerator engine. I've been developing it to fly faster. Faster than anything in the universe. I want to go the speed of light.
Oh, I hate to break this to you, Pin, but traveling at the speed of light is impossible. Our universe just has some insurmountable laws that we can't change, and the speed of light is one of them.
Yeah, that's what I thought too. It all seems so hopeless. Good thing I'm a genius!
Whew, okay.
I thought, why not just change the rules? Why can't we change them? Make light even faster? Just think, no limits. So, I made this! About an hour ago, I started to run some tests. Unfortunately, it didn't work the way I had anticipated. seems my machine has thrown us into a parallel universe. A what? You woke us for this? Why would you mess with our universe? Level with me. Is this another one of your poorly timed jokes again? No.
This isn't a parallel universe. Everything is exactly the same as it was.
It does appear that way. That's why I'm not sure anymore.
Phenomenal stuff. Oh, phenomenal danger! What if the world that you dropped us into is one that's hostile to us? Wherever we are, we can't stay here.
That's the problem. When I push the lever, we go back. Unless we are in our world now. Then when I push the lever, we go straight to the parallel world instead, and it reverses. So we have to be absolutely sure first. When I pull this down, we switch wherever we are. See? No!
Well, what should we do?
But how can we know? Are we in a parallel world now? What's different? All the rules seem the same. Solids are solid. Liquids are liquid. I wish I knew some way to tell. It could be something so small that we never even noticed.
I've got it! We can check the simplest laws of physics that we remember and see if they ring true to what we know. If the basics are the same, we're probably in our very same world.
Fantastic! Where do we start?
So gravity works the same, it would seem. Oh, Carlin, are you okay?
I've been better. Did that help?
I think we should look at a little thing called Pascal's Law.
What's that? Whose law?
It's about the force of pressure in gases and liquids.
Pascal's law goes like this. A change in pressure at any point in an enclosed fluid at rest is transmitted undiminished to all points in the fluid. That's kind of hard to understand, right? Think of it this way. If you make multiple holes in a tank of water, the speed of the water that comes out will be the same out of every hole. That's because the pressure is the same. If you inflate a balloon, Pascal's law says the exact same thing. When the air goes into the balloon, it goes in all directions equally. That's why balloons are round. If Pascal's law didn't work and the pressure was uneven, we'd end up with some pretty weird balloon shapes. Actually, a lot of other things would look weird too. We can also see this law at work when we put moving water into a container. Wherever the water goes, it has to have the same pressure. So even if the containers look different, the water level stays the same. That's how this thing works. This is called a hydraulic lift. It uses this law and the pressure of water to be able to lift things that are super heavy. The heavy thing goes on the wider part, and the lighter force can be applied to the thinner section of water. Thanks, Pascal's law.
So we need a hydraulic lift and an elephant and several hundred gallons of water, and we'll be able to test if we're in our world.
Couldn't we just inflate an, balloon?
Sure, if you want to take the easy way out, I suppose. Incredible! The balloon inflates equally in all directions! Pascal's law's right! It's round, so this proves that so far the laws of physics are the same.
What are you guys up to? Ooh, is it someone's birthday? Ooh, neat! Good job! I don't know this game, but can I play the next round? All right, I'm leaving. You guys in your science club.
Go! We're busy. It seems to me that we need to run some more experiments. We can try Bernoulli's law.
Bernoulli's law says the pressure inside of a moving liquid or gas will reduce as its speed increases. Yeah, let's explain that a little better. Don't let it give you a headache. If you take a hairdryer and you put a ping pong ball into the stream of hot air, it won't fall out towards the side. This is because the higher pressure outside the stream doesn't let it fall out. The air that's moving faster, since it's coming out of a dryer, has less pressure than the air that's staying still. This very same concept is what allows airplanes to fly. Looking good, Pin. Wings are built in a curved shape so that the air under the wings goes slower. The air above has to move faster. This generates lift, and the plane can fly.
Behold, Bernoulli's law is still real. Friends, I think we may be safe.
That's a pretty cool magic trick.
Oh.
Oh. Cool stuff, guys. But now you can watch my magic trick.
All the laws we've been able to test so far have worked a little too well.
I think I'm done testing gravity.
Yes, but there's just one left. It's called Archimedes' law, and it has to do with the theory of displacement. Let's get to work.
Huh? Nope, I'm tapping out. I've had enough displaced today.
According to the tale, Archimedes stepped into a completely full bathtub. Some water splashed over the side because he filled up the space. He yelled, "Eureka!" The thing he figured out was this. An object that enters a space full of water or gas will experience the same force that the liquid or gas has. As a result, sometimes in water you can float, or just make a mess. To see Archimedes' law in action, we need to put a spring scale in some water. Check it out. When you put the scale in the water, some water gets displaced. And also, the weight is now lighter because it's being held up by the water. Gases work in the exact same way. Balloons are able to float in the air, and ships are able to stay afloat on water because of Archimedes' law. All of these laws of physics work together every single day. So does this mean I can fly too if the air is heavy enough? No? Okay, never mind.
Fascinating! The weight has decreased. This proves Archimedes' law is in effect. We are in our own world.
Wonderful.
Yes.
Well done. Bravo.
Anyway, I present my magic. All right. It's great, right?
Pull the lever, Pin. Yeah, great. Now try it again.
Crash, why?
Yeah!
Look, everybody, I found Earth.
Phenomenal stuff!
Cool. What's next, guys?